Welcome to the video on z-values and inverse normal calculations. So first we'll learn about what a z-value is. A z-value is a number showing how many standard deviations a value is from the mean. So this is the equation for how you calculate a z-value. So x is the number, you're curious how far it is from the mean. Mu is your mean, and sigma is your standard deviation. The probabilities and values can be found using a z-value and a normal distribution with a mean of 0 and a standard deviation of 1. So for your z-values, the mean is 0 and the standard deviation is 1. So if you had a distribution that's normal, where your mean is 10 and your standard deviation is 1, and you wanted to know your z-value when x is 12, that would be z equals x minus mu, which is 10, over your standard deviation, which is 1. So that would be 2 over 1, which is 2. So for when x is 12, your z-value is 2 for this distribution. Next, we have inverse normal, where you have an unknown mean or standard deviation. So if you're given the mean or the standard deviation and information about one area, to calculate the missing value, you would calculate the z-value for the desired area using a mean of 0 and a standard deviation of 1, and then you would plug in that z-value, x value, and the given mean or standard deviation and solve for the missing value here. So for example, this says find the mean if the standard deviation is 2 and the 70th percentile is 20. So our 70th percentile is 20, so when our area equals 0.7, our x value will be 20. So we're going to use our calculator and go to our inverse normal, where the area is 0.7, the mean is 0, and the standard deviation is 1. So this is how we calculate our z-value. So you'll click second vars, which is your distribution, and put in an area of 0.7, a mean of 0, and a standard deviation of 1. And when you hit enter, you'll get that your z-value is 0.5244. So now we know our z-value, our standard deviation was 2, and then we have an x value. So we have 1, 2, 3 of the things that it needs for this equation here. So z equals x minus mu over standard deviation. So 0.5244 equals 20 minus mu over 2. We'd multiply both sides by 2. And then we'd solve for mu. So mu equals 20 minus 2 times 0.5244, which is 18.9512. So we would say that mu is approximately 18.95. So that's what you would do for these problems. Next, we can use inverse normal to solve for an unknown mean and standard deviation. So if you're missing both the mean and the standard deviation, but given information about two areas, then you'll calculate the z-values for the desired areas using a mean of 0 and a standard deviation of 1. Then you'll plug in those z-values and x values into your equation and create two equations with two unknowns, which you can then use to solve for mu and sigma using substitution or elimination. So in this example, it says find mu and sigma if the 90th percentile is 37. So when the area is 0.9, x is 37, and the 15th percentile is 12. So when the area is 0.15, then x equals 12. So we'll start by finding our z-scores using inverse normal. The area is 0.9, our mean is 0, and our standard deviation is 1. So that gives us a z-score of 1.2816. And for our other one, we'll also find our z-score. So we'll use inverse norm. The area is 0.15. The mean is 0 and standard deviation is 1. So that gives us a z-score of negative 1.0364. So the reason this one is negative is because it's below the mean. So now we'll plug these values into the equations. So z equals x minus mu over standard deviation. So 1.2816 equals x, which is 37 minus mu over the standard deviation. And for this other one, we have negative 1.0364 equals 12 minus mu over the standard deviation. We'll solve this first equation here for the standard deviation by multiplying by the standard deviation and then dividing both sides by the z-score. So we'd get that the standard deviation equals 37 minus mu over 1.2816. And then we can plug that in for the standard deviation on the second one because the standard deviations have to be equal to each other as well as the means. So we get negative 1.0364 equals 12 minus mu over 37 minus mu over 1.2816. So we'll multiply both sides by 37 minus mu over 1.2816. So we'll multiply this by 37 minus mu over 1.2816. So we have 37 minus mu over 1.2816 times negative 1.0364 equals 12 minus mu. So when we do 37 divided by 1.2816 and multiply that by negative 1.0364, that gives us negative 29.921 minus mu times negative 1.0364 over 1.2816 becomes plus 0.8087 mu equals 12 minus mu. We'll add 29.921 to both sides, which gives us 0.807 mu equals 41.921 minus mu, and then we add 1 mu to each side, and that'll give us 1.807 mu equals 41.921. Then we divide both sides by 1.807 to get that mu equals 23.199. So now that we've solved for mu, we can plug that in to find our standard deviation. So if we plug that in here, we get our standard deviation equals 37 minus 23.199 over 1.2816, which equals 10.769. So mu would equal 23.199, and your standard deviation is 10.769. So that's it for this one. So here we have our first IB practice question. It says your baby's length is 22 inches and in the 99th percentile. Your friend's baby is the same age, but is only 18 inches and is in the 36th percentile. A, what are the mean and standard deviation for a baby's length at that age, rounded to the hundredths place? So we don't know the mean or the standard deviation. We know 22 inches, so an x value of 22 inches is in the 99th percentile, so the area would be 0.99. So our z-score equals the inverse normal of an area of 0.99 with a mean of 0 and a standard deviation of 1. So that equals 2.326. The other baby is 18 inches, so x equals 18. It's the 36th percentile, so area equals 0.36. And our z-score is the inverse normal, where the area is 0.36, mean is 0, and standard deviation is 1. So that is negative 0.358. So our z-score equals x minus mu over the standard deviation. So 2.326 times the standard deviation equals 22 minus mu. So if we solved this for mu, mu would equal negative 2.326 times the standard deviation plus 22. For the second one, our z-score equals our x value minus mu over our standard deviation. We can get rid of our fraction by multiplying by our standard deviation. So we have negative 0.358 times the standard deviation equals 18 minus mu. So we'll go ahead and plug in our mu here into this equation. So we have negative 0.358 times the standard deviation equals 18 minus negative 2.326 times the standard deviation plus 22. So negative 0.358 times the standard deviation equals 18 plus 2.326 times the standard deviation minus 22. So if we combine our like terms, we get negative 0.358 times our standard deviation equals 18 minus 22 is negative 4 plus 2.326 times the standard deviation. We'll subtract 2.326 times the standard deviation from both sides to get negative 2.684 times the standard deviation equals negative 4. And then if we divide both sides by negative 2.684, we get that the standard deviation equals 1.490. Then we can plug that into this equation here. So we get mu equals negative 2.326 times our standard deviation, which was 1.490, plus 22, which equals 18.534 inches. So the mean equals 18.534 inches, but we need to round it to the nearest hundredths, which would be 2 decimals, so we'll get rid of this 4 here. So it's 18.53 inches, and our standard deviation equals 1.49 inches. So there's your answer to part A. Then for part B, it says how long to the nearest inch is the baby in the first percentile. So our x value equals inverse normal of the area, which is 0.01, and then the mean is 18.53, and the standard deviation is 1.49. So we can enter that into the calculator and get that x equals 15.06, which they want us to round to the nearest inch. So the baby in the first percentile would be 15 inches. And that's it for this problem. Now we have our second IB practice question. It says the variable W is a normal distribution with a mean of mu and a standard deviation of sigma. It is given that the probability that W is greater than 12 is 0.04 and the probability that W is less than 3 is 0.01. Part A says where Z is the standard normal variable, the probability of Z is greater than X equals 0.04 and the probability that Z is less than Y is 0.01. Find X and Y to the thousandth place. So this is going to be the same as this one, but we need our z-score. And this is that z is greater than x. So if we draw our distribution here, the probability that z is greater than here is going to be 0.04. With our inverse normal, it calculates the area on the left side, which would be 1 minus our 0.04. So this is going to be 0.96. So we need to do our inverse normal, where the area is 0.96, the mean is 0, and the standard deviation is 1. So that gives us a z-score of 1.7507. And it wants our answer to the thousandths place, so that would be 3 decimals. So x equals 1.751. Now we need to find y, which is using a z-score for this one. So our z-score is going to be the inverse normal, where the area is 0.1 because it's less than that, and then the mean is 0 and standard deviation is 1. So that gives us negative 1.282. So y equals negative 1.282. So that's part A. Then part B says find mu and sigma correct to 2 decimal places. So for this first part, our z-score is 1.751. That equals our x value, or in this case, it's our w, which is 12, minus mu over our standard deviation. So 1.751 times the standard deviation equals 12 minus mu. So then we know that mu equals negative 1.751 times the standard deviation plus 12. For our other equation, we have negative 1.282 as our z-score, and that equals 3 minus mu over the standard deviation. So negative 1.282 times the standard deviation equals 3 minus mu. And we could solve for mu here as well and get that mu equals 1.282 times the standard deviation plus 3. So now that we know what mu equals for both of them, we can set those things equal to each other. So we get negative 1.751 times the standard deviation plus 12 equals 1.282 times the standard deviation plus 3. So we'll add 1.751 times the standard deviation to both sides to get that 12 equals 3.033 times the standard deviation plus 3. Then we'll subtract 3 from both sides, and we get that 9 equals 3.033 times the standard deviation. And then when we divide both sides by 3.033, we get that the standard deviation equals 2.967. We can plug that in and find mu. So mu equals 1.282 times 2.967 plus 3, which equals 6.80369. We need to round to 2 decimal places, so mu will equal 6.80, and our standard deviation will equal 2.97. So mu equals 6.80, standard deviation equals 2.97. And that's it for this problem. So in summary, a z-value is a number showing how many standard deviations a value is from the mean. The probabilities and values can be found using a z-value and a normal distribution with a mean of 0 and a standard deviation of 1. If given mu or sigma and the information about one area, you can calculate the z-value and then plug in that z-value, x-value, and whichever you were given, the mean or the standard deviation, and solve for the missing one. But if you're missing both the mean and the standard deviation, but you're given information about 2 areas, you can calculate the z-values and plug in your z-values and x-values to create 2 equations with 2 unknowns, and then solve for mu and sigma using substitution or elimination. That's all for this video. Thank you for watching.